Hi! In this video, I'd like to go through the process of canceling, deactivating, or expiring, or whatever you call it, our authentication tokens. A few weeks or months ago, I published an article along with source code how we can leverage the JSON Web Tokens within ASP.NET Core platform and how we can generate them and then create the refresh tokens for them. So in this video, we'll go through one of the last missing steps, and we'll focus purely on the JSON Web Tokens, nothing like identity server or OAuth. So what can we do with expiring or canceling our JSON Web Tokens? So we have basically three options. The first one is that, well, we could just simply remove a token from a device, but that's really just removing it, right? I mean, someone could reuse this token and, well, it won't be re-cancelled. It will just remove it on the client side. The other solution is to keep our lifetime of the JSON Web Tokens relatively short. It can be 5 minutes, minutes, or whatever that makes sense. So even if our token is compromised by some hacker, then after a minute, it gets expired. So no one can ever use it again. But we'll focus on something much more practical today, and we'll actually create an endpoint and an action that will expire or cancel our token. And in order to do it, we'll use so-called blacklisting. So we'll keep somewhere in memory, in cache, or in database, list all of the tokens that were expired, and we'll write a simple middleware to always check whether the token is active or not. Okay, so let's start by creating a new service. I will put everything into an interface and into middleware so it can be reusable and, well, tested. So I will create a new interface and I'll just call it iToken Manager. Within my iToken Manager, I will create two basic methods. So the first one will be called something like isActiveAsync. So this method will be responsible for determining whether our authorization or authentication token is active or not. And the next one, of course, this one has to return Boolean. And the next one we'll call deactivateAsync. So this one will be responsible for deactivating our token. And of course, we can go one step further. Since we have two methods that can accept any token and check whether it's active or whether it should be deactivated, we can also create two helper methods. So one we'll call isCurrentActiveAsync. So this one will mean is current token for the current user actually active or not. And a second one will be similar to this one, and we'll just call it deactivateCurrentAsync. So based on our HTTP context of the current user, we'll check if his token is active and we'll deactivate his token if he wishes so. Now let's implement our interface. So I will just create a new class here, move it to a different file. And I will mark all my methods as async, of course. Let me reorder it a little bit. So this one will be there. And okay, that's fine. So let's create a new constructor here. And into our constructor, we'll inject the following things. At first, I will inject a distributed cache. And why the distributed cache? Well, if you are certain that you will host your app on a single server and there will be only a single instance of your app, you can try with just default memory cache available in the framework. However, it's not that reliable. At first, if you have more than a single instance, well, then you are sort of doomed. Because you can, say, have a blacklist of expired or cancelled tokens on a server A, on an instance A, and then on an instance B, there's a different list. So whether your load balancer decides that the request goes to server A or B, you cannot be certain if the token was expired here or not. So if you want to be able to actually have more instances of your app, whether it's a monolithic app or you are working with microservices or anything else which is distributed, always use some centralized caching. And the best cache possible is to use Redis, so we'll use Redis here. Okay, so this is our distributed cache and the reason for using this one. And the next one is the iHTTP context accessor, because we want to be able to access our current HTTP context for the particular user. Let's inject this one. And finally, I will inject here iOptions, and I will just call it Redis options, or actually the JSON Web Token options first. So here we'll use our JSON Web Token options that is available here in our models directory, because we want to, once we cache our token, we don't want to store it forever. So if it's on a blacklist, after a given period, let's say 5 minutes, we want to remove it from a cache. So we'll just make use of our token lifetime. So as you can see, within our app settings JSON here, we have our expiry minutes. So we'll just mark our cache to remove this key from it after 5 minutes. Okay, so let's pass our JSON Web Token options here. Okay, and of course inject it properly. All right, so now let's get into our logic behind this. So the first one we'll implement is get this active token and then deactivate async. So let's start with a simple helper method below. This one will be only for getting our cache key. So just call it get key. And for my token, I will just return a string, something like tokens, token deactivated, or whatever makes sense for you. And then I will make use of our key in order to implement this and this method. So for isActiveAsync, we can do something as simple as await cache getStringAsync, and we'll get our token key, so get key for a token. And we want to make sure that our token is null, because we'll only keep the blacklisted tokens. So if we find a token in our cache with this value, then it means that it was deactivated and the user shouldn't be able to do anything that requires authentication or authorization. And now another task. So we want to deactivate our token. So I'll just call my cache again, and I will say cache setStringAsync. And of course, I'll get my key again. And now I want to set any value that makes sense, as long as it's not an empty or a null string. So it can be even a simple space or whatever. Anything else doesn't matter, as long as it's not null and empty. And here I want to provide new distributed cache entry options. So this one. And I want to be able to expire my token automatically via Redis. And I will just call absolute expiration relative to now. And I will make use of time span from minutes. And I will provide my JSON Web Token options minutes here. So something like this. Value.expiry minutes. Okay. And now we can implement our two helper methods here. So isCurrentActive token will just make use of isActiveAsync. And this one will make use of deactivateAsync. So how can we get our current token? So again, let's implement another helper method below. And I will just call it get current token async. So at first we'll take our authorization header, see if it's there, see if it's present or not. I will make use of my HTTP context accessor, and then I will invoke my HTTP context request headers. And I will look for a header named authorization that is being used for the authentication and authorization purposes. And I will say if our authorization header equals string values empty, then we'll just return an empty string or a null. It means that our token isn't present. And if it's not empty, so if it's there, then we'll just take the first value of a header and we'll make a split for a space and we'll take the last value. Why to make a split here? Because our token looks something like this. Bearer space your access token. Okay, so that's why you have a split by a single space here, and that's why we take the last element, which is actually our token. Now I can finally implement these two helper methods. So isCurrentActiveToken will do something like isActiveAsync and getCurrentAsync, and of course await, and deactivate current async. Here we'll just say await, deactivate current async, and we'll get deactivate async. Sorry for this typo, and get current async. Okay, so we have implemented our core, let's say, business logic behind the invalidation or cancellation of the access token. Now let's create a middleware. So it's so that it will be checked every request. I will create a new directory here, or we can use our services, doesn't matter. So okay, let's put here into our services, and I'll just create a new class. I'll call it Token Manager Middleware. So I'll implement the middleware. We can do it as previously, just pass our request delegate and create it like this, or we can make use of the available iMiddleware interface as well. So I will just say implement missing members, and here I will also inject my iToken manager. So this one will get injected every request. Okay. Now I will implement my middleware, which is very straightforward now. So at first I will see if my token is active. So if token manager is active async, or actually is current active async, because we want to just check our current token for the particular user, then I will just call the next step, right? Next middleware, and return. If it's not, then it means the token is on the blacklist, and we shouldn't allow the user to actually go further with his request because it was deactivated. So I would just say context response status code equals HTTP status code unauthorize, which is for 1. So this is all about our middleware using the iToken manager interface. Okay. Now let's get into our startup class. Here we have to do a few things. So at first we have to register our middleware. So I'll just say services at middleware, or actually a transient here, because these are our services, not the middleware. So I'll just register my iMiddleware, which in this case is the token manager middleware. Okay, and now I want to use the middleware. So I can just say update. Well, here we need to also use the application and our final middleware, which is the token manager middleware, like this. Okay. And well, the final step is to actually at first implement the endpoint in our controller to be able to cancel the token, as well as provide the settings for our Redis. Okay, so what we want to do within our app settings is to add a section here. I'll call it Redis with a single property named connection string, and I will set its value to the local host, because as you can see here, I have my Redis running, actually through the Docker, but it doesn't matter. I have my Redis running here, and if I go into my Redis CLI, you can see that for now my Redis database is empty. Okay, so here we have our Redis with the connection string set to the localhost, and I need to say services at distributed Redis cache, and here I have my Redis options, and I will say Redis dot configuration equals configuration of Redis connection string, just like this. Okay, so this one will assign my localhost to the configuration property of my Redis. Okay, let it be like this. So now the final step, let's put into our account controller here the operation for canceling our tokens, so we can make it a delete or a post or whatever. I will just say tokens, let's say cancel, like this. It can be post or we can make it a delete, whatever makes sense for you. Just keep in mind that here we won't be providing any token. So I will just call it cancel access token, just to name it so it makes some meaningful. So it has a meaningful name. And I will inject my token manager, and I will just call token manager dot deactivate current async, and of course await this one here and put the async keyword. Okay. Oh yeah, lovely update. Okay, like I said, we could provide here some parameter through the endpoint or through the class. We could make this method to cancel all of the user tokens by storing them somewhere in the database. But for now, we'll just simply call tokens cancel, and it will cancel our current active token. And finally, let's get back into our startup class. So we have registered our middleware here. We also need to register our service. So I will just call add transient. For my token manager, I want to use token manager. And if I want to make use of the HTTP context accessor, I need to also register it, at least here in this version of the framework. So I'll just say HTTP context accessor and register it in my container like this. Okay, so it seems that we have prepared everything that we need. Our token manager that uses the cache, which is Redis in that case, the context accessor, and the options for our JSON Web Token. And our JSON Web Token options and all of the JSON Web Token handling is available within our JSON Web Token handler class, like this. Okay, so I think it's high time that we actually run our app. And let's put a breakpoint here. So I will just put it into my middleware. Let's say here, and then into my controller. It can be here. Okay, and I will start my app. Okay, I want to run it with default debugger. Nothing fancy options. Okay. So the app is starting. Alright, it's almost there. I have prepared my Postman Collection here, which is of course available as a part of the repository. So I will just call at first signup method. So I have new user created in the memory. And as you can see, we already hit our middleware, so it's fine. The token is not in use here. I have created my user, then I will sign in for the given credentials and we'll hit our endpoint again. And now let's get our access token. And we can try to get our account, which is the operation that actually requires the token passed along with a request. We hit our middleware again. We get our response back from the server. So now I will try to call my cancel for the token. I send it. It's there. We hit our controller. Okay. We got the no content. So now let's check the Redis. And here in the Redis CLI, we can see that we have a new key, which is tokens, our token deactivated. And we can type TTL, which is time to live. And as you can see, it goes down. Second and a second and second goes down. So after 270 seconds, it will be removed from our cache. And it's totally fine because for the time being, our token is blacklisted. So it will return something like unauthorized. But once it's gone from our cache and is no longer blacklisted, then it means it is expired. So it's totally fine and safe. So now let's try to get our account again. And I will put my token here, which was expired. And let's hit. So as you can see, our middleware hit the unauthorized code because our token has expired. And well, that's pretty much it. Everything seems to be working just fine. And that's how easy you can get started with your journey into the JSON Web Token management, such as creating tokens, refreshing the tokens, and canceling or deactivating the totally by your own. Thanks for watching.